maybe I will just introduce the subject, and we will develop this half an hour together. We will present our solution of a Venturi tube called the EcoTurbo Venturi. EcoTurbo Venturi is a special Venturi patented by CleanAir Europe. A Venturi that is to be used together with a cage, a filter bag cage in a dust collector to increase jet pulse technology and have better efficiency, both for energy savings and longer life of filter bag. It is possible to make some questions. The chat is open, and we will answer the questions after the speech. The speech will last about half an hour. So let's wait a couple of minutes, then we are going to start. This study has been made together with Polytechnic of Milan. It's a main Milan university, specifically with the Department of Civil and Environmental Engineering, because we have used to determine our EcoTurbo solution simulation models and simulation software, very expensive simulation software owned by the Polytechnic of Milan. So we are going to start now, and just give me 1 minute. Basically, when we look at the efficiency of jet pulse technology nowadays, we discover that this best available technology, of course, is working, but there are still room for improvement, especially in the cleaning of the filter bags. Basically, we have to reproduce in simulation model a situation where some injected compressed air is used to clean the single filter bag or the raw filter bag in a dust collector by scrolling the part of the dust that is in the dust cake down to the hopper. And this activity is commanded by a differential pressure, normally evaluation. So the difference from the pressure in the clean vacuum and the dirty vacuum is measured until threshold limit, and then the injection of air is released. By looking to the literature that we found in academic papers, we found some scientists and engineers that have developed academic paper looking to reproduce and use simulation technique like computational fluid dynamics inside the technology. And particularly, we based our study on one academic paper made by the Chinese in 2019, the University of Shanghai. That's called Yuan Chen. Basically, Yuan Chen have imagined a particular kind of device, Venturi tube, that could work onto 2 different variables that could be checked and simulated in computational fluid dynamics. These variables were the peak pressure that is injected by the air system, the jet pulse air system, and the peak pressure arrival time. Of course, the biggest is the peak pressure, and the lowest is the peak pressure arrival time at the end of the filter bag, and the more is impacting the dust release cake, the cake of the dust, the release of the dust cake. That means, of course, that the stronger intensity pulse and a more faster pulse could release a higher quantity of dust from the filter bag, thus reducing, of course, the frequency of the cleaning required at the filter bag, and improving the overall efficiency, the energetic balance, and elongating the lifetime cycle of the filter bag as well. By simulating, of course, why simulation is a good mean for dust collector to look to new technologies and implementing molds, and so developing devices to be installed, because the dust collectors are very often harsh environments, hostile environments with limited access to people, and only in offline conditions, while putting this dust collector in offline condition is very expensive, because the dust collector, of course, is working continuously, very often 24 hours a day, because it has to clean the quantity of the dust coming from the process. Simulating could help to solve this issue. Requires times of some burdens and size constraints to be determined. So the model should well placed, be well done in order to represent the reality. But it's a very good mean to avoid to access to plants very, very often not owned and plants that we could not stop. So by coming more deep into this study, of course, we have imagined a pipeline of filter bags, and the study has been done according to the following phases. First, of course, the simulation model has been validated by looking to its physical consistency. Some background conditions must be analyzed, like a computational mesh, for example, or time step, how we divide in simulation the space and how we consider the time, but also which equation we shall use, which model of equation we should use. And we cross the typical equation of fluid dynamics with the typical equation like a Duffy laws of the filter bag fabric. And thus to come to validate the concept of Liu Shen that a specific device made in some way could improve the peak pressure and improve the peak pressure arrival time, so the speed of the jet pulse. Thus to determine how we can change this shape of this validated solution to a proper solution that later on we patented as EcoTurbo. So the application, experimental validation of different solutions with a final application means that here we made a 3D injected testing purpose device, and we went to instrumental characterization to test it on the field. So in real condition with real tank, real valves, validating this again, not only by mathematical model, but on field by measurement with sensor. And then at the end, realizing the final product. So we are going to see how we develop this EcoTurbo with these following steps, one by one. And of course, as you can see in these graphs, the two variables that we analyzed were the peak pressure. You can see here peak pressure is PA in Pascal, no? And this on the horizontal axis is the length of the probe. We imagine a 10-meter length filter bag. And in orange color, you can see instead the other variable that we have checked, which is the arrival time of this flow peak pressure peak at the end of the probe until 10 meters. Many aspects has been considered, especially to sensitivity analysis. I've already said before, time discretization, computational mesh, numerical settings, post-processing. By looking at the highs, the Liu Shen study, you can see in his image on the upper part, this Venturi is uplifted onto the collar and thus letting some extra air inlet during the cleaning phase. So we are going to analyze if this solution was better than the traditional solution used by Venturi, by the traditionally installed Venturi in the market. The first step has been, I will go rather fast here because it's a little more theoretic. So the first step has been to consider and find the trade-off in between the time of simulation and the two main variables, time and space, which can impact the time of simulation. So computational time of computer requires days. We found a good compromise, and we make a sensitivity analysis to determine that a time of 10 minus 5 seconds is enough to have a clear simulation, a real simulation, and comparing to reality, and a 50K, so 50,000 small cells to, let's say, realize the domain of investigation. The axial domain of investigation that we did by considering one single filter bag injection by the nozzle. Other data has been considered by Polytechnico. This study has been made by Polytechnico with ANSI software, very expensive software. And they have, of course, they are the only one that could validate, frankly speaking, this kind of without committing mistakes. So we cooperate with them. They made also a sensitivity analysis, for example, by considering permeability coefficient, so by varying the permeability of the filter bag and seeing what was happening to the model, or more technical evaluation about the kind of equation or Navier-Stokes equation used and turbulence model used. At the end, the first discovery was something we already know from the market, and the fact that the Venturi installed on the collar of filter cage is that the peak pulse pressure is increasing 25% in this case by comparison with a not installed, so simple collar Venturi solution. So Venturi increased this capability of the hair to increase the peak pressure and to arrive faster at the end of the filter bag. Now, in our study, we evaluate 4 different solutions, and you can see that the layout Venturi tube and layout Venturi free are very similar to the Liu Shen model, to the Liu Shen study. So we made a study based not on absolute value. We just tried to compare the results by a comparison among them. And what we gain is these 2 graphs, where the Venturi solution in black, which is layout Venturi 2, is the best standout performer. That means he has the highest at each meter evaluation of the filter bag, so the highest peak pressure and the lowest arrival time at the end of the bag. There was another aspect that should be considered. It is the mass of entrained air, so mass flow or flow, that is considerably higher in the case we have the Venturi detached from the top collar of the cage, of the filter bag cage, in a quantity that we have also determined physically and not only by simulation. Now, of course, this carry us to imagine a new shape of Venturi that is uplifted, but we wonder, but what about the shape of the Venturi? Okay, it's uplifted, but Venturi has different throats, has different length, could be wider or narrower, and how can we choose the best solution that will impact and raise this black curve on the left even higher? So we started to make an analysis in computational fluid dynamics. We are still in this phase by considering each of these dimensions one by one, varying them. What is happening, for example, if D2 is increasing, if D2 is decreasing, by keeping the others at the same. Each evaluation took us 1 week, about 1 week of computational time, took to the Polytechnical 1 week of computational time. And so all this process lasted 1 year and a half, since the beginning up to determine the results. Of course, the results are now in the hands of CleanAir, part of the CleanAir know-how. Some we can release, some not. That's what we are releasing now. And at the end, so this study comes with a hypothetical solution. The hypothetical solution, you can see it here on the left, is called EcoTurbo. EcoTurbo is now a product made by CleanAir and patented with a European patent in CleanAir. This solution comes from the study where we changed every dimensions and found an optimal shape for the Venturi. As you can see here, Venturi is uplifted, and there is a space in here to let some additional air, like dilution, come in. So to better the air inlet, better the peak pressure arrival time and the peak pressure intensity. On the right, you can see a traditional Venturi, which is commonly used in the market. And when we look at computational or the results of the computational analysis we did, we just act by comparison in order to be sure that any burden, any potential conflict, or any potential feeble point in our system, let's say in the conditions, in the background conditions of the study that we did, will not impact the reality. So we cannot be 100% sure that what we gain by computational fluid dynamics is 100% correct, because it depends on so many variables. But what we can be sure is that if we use the same system background conditions to consider the Venturi on the left in regards to the Venturi on the right, then we can state it's better or it's worse, at least according to these parameters we have evaluated impacting the cleaning efficiency of the filter. What we discover by looking to this traditional use comparison to the traditional use Venturi in the market is that EcoTurbo was performing better. So you can see the red again. And of course, we check in the middle of the cage, we check on the border of the cage close to the filter bag, but the results doesn't change. EcoTurbo was performing better, is performing better. This for cleaning, but EcoTurbo is also performing better in working conditions, that I will explain later. By looking to some figures, computational dynamics, we are still there in simulation model. We can see that 3, 4, 5 meter lengths of the filter bag, we have 50%, minimum 50%, around 50% increase in the peak pressure on respect to traditional Venturi. And the same in the speed, so the peak pressure arrival time at the end of the bag. The mass of entrained air, or the flow, is also increased in the big Venturi. We calculated by simulation the quantity of air entering in half a second in the Venturi. And we see that this is also a substantial increase in the quantity of air that could be used for clean the bag, to clean the bag. Of course, once this EcoTurbo Venturi has been designed, and we make one samples in 3D plastic molding to go testing the samples on fields, because we were still lacking a characterization of on-field characterization with sensors, pressure sensors. And we concentrate especially on pressure sensor. You can see this device, the pictures in the middle, is holding the pressure sensor inside the cage. And we measure the peak pressure with sensor going to, thanks to Autel, which is a well-known tank and valves, diaphragm valves used for jet pulse simulation, where we confronted the, let's say, sample of the EcoTurbo again towards the traditional same Venturi that we have made the simulations in computational fluid dynamics. So we place sensor, in this case up to 10 meters, we place 5 sensors at different lengths. We know that after 5 meters, the peak pressure is decreasing of 1/10 order. And so, of course, our main purpose was to look what was happening until 5 meters, because then from 7 to 9 measurement, the potential mistake in measurement is raising. And what we discover is that the peak pressure was both on the positive side and the negative side increased on respect to the traditional wave. And so it is realistically leading us to the conviction that we could release much powder, much dust onto the hopper. Again, we validate by observing a minimum value and a maximum value, so making also a range analysis, that at P1 and P2 positions, P2 position is 5 meters and P1 is 3 meters, we have evaluated this simulated peak pressure by looking at what was happening really in our simulations on field, so with the sensors. And we discovered that the special shape of EcoVenturi was able, on respect to the traditional Venturi tested in the same conditions, to have up to 50% more peak pressure at 5 meters. And 3 meters as well, with a sensitive increase. So the computational fluid dynamics has been validated in assessing better peak pressure and better arrival time of our EcoVenturi turbo solution with respect to the traditional solution. Of course, this is continuing. We are continuing this test nowadays, and we are going on fields, on real conditions. Okay. Well, this is the design of EcoTurbo. EcoTurbo has been made in 3 different designs to be able to satisfy all the cage's needs. Actually, is available in already molded in the middle size, which is a cage from around 135 to 155. What are the main characteristics of EcoTurbo? EcoTurbo has been made to be detachable and easily installable for easy installation on a flanged collar, so by riveting or by screwing, is in aluminum, recyclable, and it holds one position for here in this point to apply our EcoSmart tag, so digital tag for identification of cage and filter bags. You can see that there is a space from the Cola to the Venturi. This additional space is the one that is exploited in the Liu Shen study to increase the air inlet during the cleaning phase. But another advantage that this solution has is that in working conditions, the closing of the Venturi on the top cell plate is not decreasing the inlet potential area because of this space. Basically, the Venturi is not clinched onto the collar by limiting the exiting of the air, but uplift in a way that a part of the air could come out outside the Venturi, so that the section that is decreased to the nominal section of the cell tube is just the thickness, 2 millimeter of the Venturi itself. So a Venturi that is not requiring fan energy during the working conditions, because if we decrease the energy of air and the quantity of air compressed during the cleaning by reducing the frequency, we gain another aspect. We have less energy of the fan because we are not limiting the exit, and we lower the differential pressure by lowering the frequency cleaning that is present in the dust collector on the average, so requiring less power to the fan as well. Of course, if a fan could be regulated. These are the three sizes of Venturi, of EcoTurbo. So from the smallest color, 120, up to more than 160. This is a real picture of the EcoTurbo Venturi now, and the advantages that EcoTurbo could grant it and first imagined with computational dynamic and then demonstrated by physical characterization. On the right, you can see the effect and why at the end we made this trip, this journey towards better Venturi. Because first we discovered there was room still to better this old invention from an Italian scientist. How to better? Just because it could decrease the frequency in certain conditions of the cleaning by lowering differential pressure, by lowering the time a certain differential pressure is present. So that means reducing air compressor, reducing energy of the compressor. That's not so much because the most of the energy coming from the fan, we know. But by lowering the pressure in the plant, we also reduce the fan consumption. Basically, we are in a point where we have a best score, where we are not limiting the exit. By placing a Venturi to better cleaning performance, we are not worsening the working conditions of a filter where we study air filtration area, and then we are limiting the possibility to treat the air by placing a Venturi that is closing and working. At the same time, we have a better cleaning, 50% of peak pressure more. How much is in terms of releasing the dust cake? Depending with so many variables, that's not easy to assess. Sticky dust, not sticky dust, condition, temperature. There's a lot of variables. What we know is we produce a more intense peak pressure, but not just acting on the compressor, just acting on a specific tube, metallic tube, with same cost of what is already existing, and with facilities to be mounted, so sustainable. We are reducing energy, we are sustainable. We are making sustainable parts, spare parts that could last over the time, because if you can detach, you can change and replace. Spare parts which are made in aluminum, which is a recyclable material. So at the end, our solution is something that we try to push to the OEM manufacturer and to the end users. We all know how it's difficult in this industry to convince end user to change something, but it's a lot of money at the end of the year, or in the cycle lifetime of a dust collector saved in energy. And this is such a low cost solution because it doesn't change anything on that we think it was worth to make it is worth to advertise it and make some webinar to try to explain what we did. Also because in the team that developed this, there are, of course, we don't speak about CleanAir. CleanAir, okay, it's a well-known company, of course, it's many years of experience in filtering and in cage manufacturing support for filter bags, but we came to work with let's say the best brains we have here in Italy at our university. Professor Scaccabarozzi is a professor of mechanical measurement, so he has the need to check the sensor pressure and use the right filters to eliminate any bias in this measurement, while Professor Messa is computational fluid dynamics expert, so he teaches the mathematical engineers in Milan University, Polytechnic of Milan. That's of course, I thank you for your passion to listen to me, and we have a catalog about EcoTurbo, and so we are available, of course, to disclose any information you might need to go deeper into this, and we will send this to the email that of the people that attended this webinar. We will send these catalogs with the link to the potential resume of the video resume of this webinar, so that if someone has come later inside the meeting could see also first part that we have introduced. So I thank you all for your attending, and EcoTurbo, it is worth consider EcoTurbo Venturi for your solutions OEM for your design of the filter. Thank you for attending. We can contact soon. Bye.